Day 2 of matrices is going to introduce row operations. Now, row operations are important because we are going to utilize those to help us tomorrow with something called Gaussian elimination. Gaussian elimination is a way for us to use reduced row echelon format to solve problems. Now, if you remember back to several days ago when we did systems, 3-variable systems with substitution, that is the end result of what row operations is supposed to create within a matrix so that you can utilize substitution to find your solutions. And we're going to eventually get to that later on in today's video, and then in tomorrow's video you're going to see exactly how that works. So today we're going to simply practice what it means to have row operations. We're going to go through several examples. In order for me to have saved time, I've preloaded all of them. So just bear with me and pause the video often if you need to catch up with whatever is happening in the notes. Okay, so the augmented matrix that I'm using is going to be, of course, the coefficient matrix here, what used to be A, and then instead of making two matrices, I've simply added what was matrix B to the end, to the last column of my augmented matrix. Now, instead of a 3x3 matrix and a 3x1 matrix respectively, now what I'm going to use is a 3x4 matrix where the last column of the matrix is matrix B, or the constant, okay? So just keep that in mind because that's going to be a significant change from yesterday until today. So here we go. 1, 1, 1, 2, 1, 1, 0, negative 1, 1. Notice that we've got to have that structure. We've got to fill in those missing values where they are. And of course 10, 12, and 3. My first row operation that I'm going to practice with today, and now understand that these are just practice for you to get familiar with how this works, but later on we're going to have purpose with which row we pick and which operation we use to help us figure it out. So right now we're just practicing, but remember later we're going to have some purpose behind our practice. In order to practice this first row operation method, we're simply going to take row 2, that's this one, and we're going to add it to row 1, which is this one. So that's what I've done here. I've rewritten row 2 and I've rewritten row 1, and I'm simply adding those numbers together. Now, if you remember back to elimination or linear combination method, that's all we're doing. We're simply taking two equations and we're just adding like terms. That's why we're able to do this row operation the way we are. Now, as a result of this row operation, we can now substitute the answer to that question into row 2. Now understand that we have the freedom to do this any way we want to in these matrices. And tomorrow when we practice Gaussian elimination, you're going to understand the purpose behind which rows we choose and why we want to do that. So today, remember, all we're doing is practicing row operations. All right, question number 2. So we've got ourselves an augmented matrix. Remember, it's 3x4. So you're writing in all of your variables and all of your coefficients and all of your constants into a 3x4 matrix. Notice that the y is missing here, so we had to write it in as 0. In this particular problem, we're asked to add row 2 to row 3, and so I've taken row 2 and row 3 out of the augmented matrix. I've added them together, and I've gotten a new row. Now, incidentally, as a result of this row operation right here, I have got a 0 in this value of the new augmented matrix. And that is part of the purpose that we are trying to use row operations for this. You're trying to get these 3 values zeros, and that's going to be the purpose that we use. So notice if we add these two to each other, we're going to get a 0 value as a result. That is starting to help you understand the purpose behind what we're doing here. All right, Now notice it's very easy to make mistakes. So please, when you're doing this on your own in practice or whatnot, please make sure that you are careful in the way that you put these numbers in. And check me, because I'm not entirely sure that I haven't made a mistake either. These are lots of numbers and they tend to run together. So if you do catch a mistake, please let me know so that I can fix it. All right, here's our augmented matrix. I've simply filled in all of those values. We're asked to conduct a row operation this time of subtraction instead of addition. Now this gets a little bit tricky since I preloaded this. I'm going to try to help you see what I did here, and maybe you can come up with your own effective method for doing this. So it says row 2, so that's why I inserted that one there. And then it says row 1. And so what I've done here is I've simply changed minus, minus, plus, plus, all of my values, because when you have a minus, you must distribute it throughout every value which is in row 1. So that's why I have opposite signs throughout the entire row 1 as my operation. All right? And that resulting value goes into row 2. That's the row operation I've been asked to perform this time, and that's why it replaces that middle row. Notice also that I have the original row 1 and row 3 from my original augmented matrix. The result of row operations only changes the one single row that I want to change as a result of the operation. I don't change anything else about it. All right, question number 4. Again, you just write them in. Remember to input your zeros where necessary. And the row operation we're asked to perform this time is row 1, that's this one, minus row 3. You'll notice again I've switched all my values, so I'll go ahead and show you what I did there. Minus, plus, plus, and minus. And I've inserted that into the new augmented matrix as the new row 3. Question number 5, same way. You'll notice that I've written in my augmented matrix. You'll notice that I performed the row operation, but now we have a new thing going on here. This is my multiplier, or my scalar as it is. So it asks me to multiply 2 times row 1. So what I've chosen to do here for you is I've chosen to start by multiplying through the value of 2 to all of row 1. As a result of that, I have this new row. And then from there, I will be adding it to row 2. So you'll notice what's happened here is my result. I've put that new value in, and remember, this was only used for row operations, nothing else, which means that I am simply going to rewrite row 2 and row 3 exactly the way they were in the old augmented matrix without changing them at all. Row operations only changes the row that we're trying to achieve and nothing else. All right, question number 6. Same as before. So we have a new scalar that we're going to use. So we've got our augmented matrix here. What I've done is I've gone ahead and multiplied row 2 first. And you'll notice I left off the minus sign, but you could have distributed a negative through there and gotten the same result. But I just wanted to distribute the 2 and then put my negative sign on afterward. I kind of did it in 2 steps instead of 1. And that's only to keep it consistent with what I had done before we had this scalar involved in our problem. So I'm going to distribute this all the way through, giving me the value of negative 2, positive 2, negative 2, and 16. Now what I'm going to do, and what I did do, was I went through and changed all my signs. So what was minus is now plus, and that's why everything has been swapped. I rewrote row 2 first. I subtracted that from row 1, giving me a new row 1, and I simply fill that value in. And so all I'm going to go ahead and do here is fill in the old row 2 and row 3 from the old augmented matrix, and then my new values will go in there. All right, question number 7. fill in your augmented matrix. You'll notice from what I had mentioned earlier, I've got two values of 0 and 0. So our purpose here is to attempt to turn this -1 into a 0 by using row 2 somehow. So the purpose here is to determine a way by using row operations to make this number and this number cancel each other out. So the purpose here is for us to add row 3 to row 2 to give us a new row 3 in which the second value is a 0. That's the purpose that we're using this for. All right, so with that in mind, we are going to add those two together, giving us this resulting row 3. And when we have done that, now you can really start to see why it is that we're putting this all together. Notice down here we have a question that we want to answer. And the question is, as a result of this new matrix, the operation we did here, can we solve the system? All right, so what I'm going to do here is I'm going to take my old augmented matrix, turn it back into, or use my new augmented matrix, turn it back into the original equation with the changes that took place. So notice now that I have a single variable. I know what the value of that single variable is. I can take that number, insert it in here, find the value of y. As a result of that, I can insert z, insert y, and find x. This is reduced row echelon format. This is the reason why we produce row operations that create this pattern of zeros inside of the matrix so that we can solve this without solve this complicated system without using too many operations.